Hello everybody, I'm going to do the presentation of WaterCAD. When you first open WaterCAD, this is the screen you'll see. So you go to File, you go to New, so here you have your new project, and before you do anything you want to make sure that you save, and let's give it a name. We're going to call it. Alright, so here's your screen, here's all your settings. So the number one thing you got to do is you got to go to options and make sure that you're just using your proper units. So you go to units, make sure everything's US customary, so everything's in feet, pounds, gallons. Alright, so that's already set. So now when you're doing the FireFlow analysis, you're going to do FireFlow and max day. Which FireFlow again is the needed FireFlow as set by the type of construction, and usually you'll submit that or you'll calculate that, and the fire safety folks will approve that number. So we're assuming you're going to be doing a 2,000 gallon per minute needed FireFlow, and then we're going to throw in the demands for some single family homes. Now again, single family homes for Orange County Utilities is going to be 350 gallons per day on average for each single family home. So you add up your number of homes, say it's 100 homes, so that'd be 100 times 350, and then you would divide that, because you want to get down to gallons per minute, so you just do all those calculations. So the way you're setting it up is you're getting a connection point from Orange County Utilities, and we'll use that as a reservoir. So we'll click on the reservoir, and then we'll set a reservoir here. And then we'll go ahead and that will be a reservoir, and then we're going to draw some pipes and some nodes. So we're going to come over here, and we're going to choose this, and we're going to draw over here. That'll be pipe 1, junction 1, and at this junction you could have it split or you could have it continue down the road, but again you're talking about the point of connection in the road is your reservoir, and you're coming into your subdivision, or if you're developing a commercial project, this could be the junction point right before your fire line master meter. So you would have to put in some losses between junction 1 and the next junction. Through that link we'd have to put in some losses. So once we get past that point, now we're just putting pipe down the road, and the way it's doing it now is it's putting in defaults. We're going to go and edit that in a minute, but basically you draw out your pipe network, okay, and it might be a big loop system that comes around and then comes back to here. Alright, and then you hit escape and you get out of it. Alright, so this is a general kind of layout. So the next easy step is you got to put the data in for the nodes and for the pipes and for the reservoir. So let's go ahead and go back to the select tool, and let's select the reservoir. All right, and then we're going to open the table. So there's different tables here that you can edit. This is the easiest way I find to do it. So let's click on the reservoir, and automatically you'll see the reservoir comes up. So you have your reservoir, and basically what you're getting from Orange County Utilities, you're getting an HGL, which is basically a combination of pressure and elevation. So you convert the pressure into feet of head, and you get a total. So let's just say we're dealing with 200 feet at the reservoir, okay? And that's all you need to enter for that one. All right. Now we're going to go back to select, and we're going to select all the pipes and junctions, and we're going to open up those tables. So we'll go to, let's start with junctions first, okay? So you get your junction tables, and the only thing you really need to enter in your junction tables is your elevations. Again, you're starting with 200 feet at the reservoir, but of that again is percent. Some of it is the pressure. Some of it is the elevation. So let's just say the whole site is about 100 feet of elevation. So we'll go ahead and we'll put in 100 feet of elevation. Now, if you're going uphill or downhill, these numbers could change. Like you might start off at a higher or lower. Let's just say that when you get to the back of the property at J4, it goes down a little bit. So we'll say it goes down to, let's say, like 90. It's the back of the property, so it flows away from the entrance where the connection in the road is. So J3, we made it 100, so we'll also let's make J5 and 6 also lower. So we'll say 90 for that one and 90 for that one. And again, we're trying to keep it really simple for this video. There are much more things that with demands and all these other things you can set at this time. But we're going to go ahead. All we're going to do is we're going to put a worst case demand of 1,000, or we'll say 2,000 GPM. We'll assume this is commercial. So we'll put a junction. We're going to put a 2,000 GPM. Normally we only allow 1,000 per hydrant, but if you put the highest flow for the worst case scenario at a 1 hydrant and all the pressures and flows still work, then we assume that that's more conservative. So you are allowed to do this, even though in reality we only allow 1,000 GPM per hydrant, but we're assuming, again, that maybe it's junction 4, junction 5, or junction 3 and junction 4. But if we put all 2,000 at junction 4, that's the furthest from the reservoir. That's going to be the worst case scenario. So you got that entered. You just close that. All right, close that. And now the only thing left to do is to fill out the pipe information. So let's look at the pipe information. So again, we have everything selected. We're going to go over to our tables, and we're going to look at the table, what it shows for the pipes. So we go here, and we go down to pipe. So we see all the pipes. All the pipes are shown here. So what's important for a pipe? Well, obviously the length. These were automatically done when I was clicking, but you couldn't override this, and you could actually put in the lengths. So the way you do that is you would make the length user defined, and you would change that. But for now, we're just going to leave these numbers here just for demonstration. It defaults to the 6-inch ductile iron. Again, it's a loop system, but I would just say, knowing about 2,000 gallons per minute, pipe 1 can't be 6-inch. It's going to have to be at least 8-inch. So we're going to look at pipe 1. We're going to make that an 8-inch. Now it defaults to a 130 for ductile iron, but that's not the way we do it in Orange County. 130 is the default for PVC. Ductile iron would actually be 120. But most people, what I've seen on private property, they use for 8 and 6-inch, they'll tend to use PVC because it's cheaper, is what I'm told. So basically, we're assuming we're using PVC. So the 130 we do not need to change. But if it did, again, that would be something you'd affect. So again, this is that simple. You've got your pipes, you've got your materials, or your Hazen Williams is the main thing that matches, and your sizes. So let's go ahead and do the next step. Everything's entered. You got your elevations, you got your pipe sizes. Make sure we got pipe set. Let me make sure we got our pipe set. There's another way you can just click on something and you can set. So it's 8-inch, 130, so we're fine. Okay. So we're going to go ahead and what they do, they call it validate. Make sure everything's connected. So no problems were found. That's a point where if you didn't click something right or you didn't connect it properly, you would get an error and you had to go back and figure out what it is, but now we can just go ahead and run it. Oh wait, before I do that, I'm going to go ahead and edit the J4. There's another way to do it. All right, so you go into demands, one item. Let's just say we'll take the entire subdivision flow, average daily flow, or gallon per minute flow as we calculate. Let's just say we're adding another 100 GPM max day flow, which is the average day flow with a peaking factor of 2. So let's just say that. So again, this is worst case scenario. If it works on that farthest node, everybody will have good pressure even during a fire for all the single family homes. or for if it's a apartment complex, all the apartments should have good flow. Let's just boost it up, because apartments might be densely packed and there might be more of a max data demand. So let's go ahead and do that. All right, so we got that, and all we have to do now is run it. So let's run it. Run. All right, so see, we got these results. 2200 was the flow supplied. And now to do the report, as you'll see in the example that I gave everybody, in the example WaterCAD report, we got to make sure we have our input data shown and our output data shown. Now I've already shown you all the input data, but when you want to look at the output data, you can now go back into the tables. So let's just highlight the whole thing again. Okay. And we'll open some of these tables. So we want to see our reservoir. So that's fine, that's still 200, but we did the 2200 flow, okay? Let's look at our pipes. The only thing we make sure with on pipes is, again, that we have all the data entered properly. But here now is your results. So these are the flows. Now we're violating some velocities. In the Orange County Utility Spec Manual, it says you can't go over 8 feet per second. So we're violating all the velocities. So that's bad, okay? So that's not acceptable. So we're gonna have to go in here and we're gonna have to modify these. We'll make this a 12-inch and we'll make these all 8-inch. Again, for residential subdivision at 1,000 GPM needed FireFlow, it probably would have worked. But for commercial, with 2,000 gallon per minute needed FireFlow, it doesn't work. So let's go ahead and just run it again. Now we made that change. We'll go back, we'll highlight everything. We'll open the table, the junction, or the pipe table. As you see now, everybody is below 8 feet per second. So there you go. That would be public requirement. Now in private, we do allow you to go over that, but why, as an engineer, would you want to violate something that is required for the public when it can cause liability for you if you don't meet it? Well, there might be some pressure on you from the developer to lower the price. And if you're using ductile iron especially, you might be able to get away with some higher velocities. But we set it at 8 feet per second in Orange County, and we do that for safety reasons. When you have too high a flow, you potentially could have a main break. When there's water hammer, somebody open a valve too fast, or closing a valve too fast, more like. All right, so those all work. They all meet they're all below the 8 feet per second, and that's what you report in your report. You give this table, and you show after the run, all the velocities were below 8 feet per second. So now you go into the table for the pipes, for the junctions, and the requirement here is nothing below 20 PSI. So we started at a pretty good elevation and PSI. So everything was fine. Everything was well above the 20 PSI. Even on the worst case, it's interesting, junction 3 is showing at a lower pressure. Junction 3 is at a higher elevation. That is why the pressure is lower here. So we didn't think that would be the worst, but apparently it is the worst, lowest pressure. So let's go ahead and let's modify this, make this 0. Make it 0 here. And we'll leave 200 on, well, okay, make that 0 too. We'll make everything, we'll put everything back on this one. So we fixed that one. Okay, let's go back to this one now. It's not letting me edit it. There we go, okay. So we'll put the 2,000, we'll put 2,200, right, all in one number. All right, so we'll close that, and we'll rerun it. And we'll watch these things change in front of our eyes. So yeah, we put 2,200 there. Still the worst pressure is 42. So we're still fine. So you report this. You put make sure your flows were justified. And that's basically it, folks. You just present that in a report saying everything was met. Thank you so much. Have a good day.